Your task for today is to complete the following 20 question grid. This is very similar to the grids that you've completed previously, but it has a new set of questions for you to practice. Because of this, I strongly recommend you watch the explanations for each type of questions before attempting it. These will appear at the end of the video. There are also video links embedded within the Show My Homework task with further help on each of the topics that are covered. You can either print the worksheet out and write the answers directly onto the grid, or do the work into your maths book or a separate piece of paper. Either way, make sure that you show all of your working out and refrain from using a calculator to answer any of the questions. Once you've completed the grid, make sure you mark your work accurately, put your score, and try to correct any of the mistakes that you've made. When you've done this, take a photo of your work and upload it to Show My Homework so I can see how you've got on. In this next part of the video, I'm going to explain how to do each type of the questions that appears in the grid. The first type of question will ask you to solve a quadratic equation. We can do this by factorising. In the first question, I'm asked to solve x squared minus 13x plus 36 is equal to 0. Because the question is equal to 0, I can factorise straight away. To do this, I need two numbers which when I add them gives me minus 13, and when I times them gives me positive 36. To help me do this, I can think about the factor pairs of 36, which are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Because 36 is positive, I can add these together to help us find which one gives us 13. So the first one gives us 37, 20, 15, 13, and 12. So the one we want is 4 and 9. Because we have a positive product but a negative sum, instead of writing 4 and 9, I know that I need to have minus 4 and minus 9 to make this work. That means to factorise, I end up with x minus 4 in one bracket and x minus 9 in my other, and this is obviously equal to 0. I can now use this to solve the quadratic. So looking at the left bracket, I know that one part says that x minus 4 is equal to 0, and that means that x is equal to 4. That's one solution. And the other bracket, so the other part, says x minus 9 is equal to 0, and therefore x is equal to 9. That is my second solution. In this second example, I'm asked to solve x squared minus 8x minus 20 is equal to 0. Again, I can factorise this. I can think about two numbers which add to give minus 8 and times to give minus 20. Looking at the factor pairs of 20, I get 1 and 20, 2 and 10, and 4 and 5. This time, because the 20 is negative, I need to look at the difference between these values. So this is going to be 19, 8, and 1. Because I want to try and get minus 8, I'm going to use the numbers which give 8, that's 2 and 10. In order to get a negative product and a negative sum, I know that one of these two values needs to be negative. This means that the two numbers need to be minus 10 and 2. So the question factorises to x minus 10 in one bracket and x plus 2 in the other, and that's obviously equal to 0. From here we can solve the quadratic just as we did before. So the first part gives us x minus 10, which is equal to 0, so therefore x is equal to 10 is one of the solutions, and the second bracket gives us x plus 2 is equal to 0, so x is equal to minus 2. That would be my second solution. The second type of question will always ask you to complete the square. In this particular example, I'm asked to complete the square on x squared minus 4x plus 6. The important part is the x bit in the middle. You want to half this amount and put it into a perfect square. So that's going to give me x minus 2 squared. I know that if I expand that, it will give me x squared minus 4x plus 4. Obviously the first two parts of this are right, x squared minus 4x, but instead of plus 4 I want it to be plus 6. So to get from here to where I want to be, I need to add 2 onto my answer. So that means in completed the square form I get x minus 2 squared plus an extra 2 in the end. The third type of question will always ask you to simplify an algebraic fraction. To do this, we want to get a common denominator. In this first question, I can get a common denominator by multiplying the left side by 5 and the right hand side by 4. This would give me a common fraction over 20. On the top, we'd get 3x times by 5, which is 15x. And on the right hand side, we'd have x times 4, which is 4x. I know that 15x take away 4x is 11x, so I can simplify this to 11x over 20, and that would be my final answer. In the second example, to get a common denominator, I'm going to want to multiply the left hand side by an x and the right hand side by 2. This is going to give me a common denominator of 2x. On the top, I get 3x multiplied by x, which gives me 3x squared, and on the right hand side 2 times 2 gives me positive 4. Because the top part cannot be simplified anymore, that will be my final answer. The fourth type of question will always ask you to expand and simplify some brackets that have surds in them. In this first example, I want to take the root 5, which is on the outside of my bracket, and multiply it by everything on the inside. So I have root 5 times by 2, that's going to give me 2 root 5. And I also have root 5 times by minus root 5, that's going to give me minus root 25. I know that root 25 can be simplified to just 5, so therefore this is equal to 2 lots of root 5, take away 5. That would be my final answer. In the second example, I need to do the same thing, but it's slightly more complex because we have simplified surds. So I want to times everything on the outside, that's 2 root 3, by everything on the inside. So the first thing that I need to calculate is 2 root 3 times by 5 root 3. I can do this by thinking about multiplying the number parts first and the surds afterwards. Doing this gives me 2 times 5, which is 10, and root 3 times by root 3, which is root 9. For the second part, I want to do 2 root 3 times by root 27, so the 2 is going to remain on its own at the front, and 3 times by 27 gives me root 81. At this point, I can see that both root 9 and root 81 can be simplified, and because they're multiplying the corresponding numbers, this gives me 10 times by 3, that's because root 9 is equal to 3, plus 2 times 9, and that's because root 81 is equal to 9. I know that 10 times 3 is 30, and that's being added to 2 times 9, which I know is 18, and therefore my final answer is 30 plus 18, which is 48. Notice how in this case all of the surds actually cancel out and we get a really simple answer at the end. The fifth type of question will always ask you to find the gradient given an equation of a line. It's really important to find the gradient that we want to get the equation in the form y equals mx plus c. If we can do this, the value of m is our gradient, and the value of c, the number part at the end, is called our y-intercept. So in our particular question, we want to get 6x minus 2y equal 10 to have y as the subject. We can do this by taking 6x from both sides. That gives us minus 2y is equal to 10 minus 6x. And then we can divide both sides by minus 2 to get y on its own. So we get y is equal to 10 divided by minus 2, which is minus 5, and minus 6x divided by minus 2, which would be positive 3x. I know that the amount of x is the gradient, so in this case I can say that the gradient is equal to positive 3. I can also say that the y-intercept is going to be at minus 5, which would be the coordinate 0, minus 5. The sixth type of question will always ask you to simplify an expression using your laws of indices. To work out this first example, I'm going to first consider multiplying the numbers and then the x parts. So 6 times by 3 gives me 18, and x cubed times by x squared, because they are indices with the same base, I can simply add the powers to get x to the power of 5. That would be my simplified answer. In the second question, I can do the same thing but with division. So 24 divided by 6 gives me 4, and this time, because we're dividing two indices with the same base, we can subtract the powers, so that is x squared, which is 6 take away 4. That would be my final answer. In this final example, I'm finding a power of a power. So I'm going to start off by taking the cubed and applying it to the 3 at the front. I know that 3 cubed is 27, and if I have x to the power of 4 and I cube it, or take a power of a power, I multiply the two numbers together. So this is going to give me x to the power of 12, and that would be my final answer. The seventh type of question will always ask you to express a number as a product of primes. In order to do this, it's always useful to recognise your first few prime numbers. They are 2, 3, 5, 7, 11, 13, 17 and 19. They obviously carry on, but that's up to 20. We're asked in our question to write 72 as a product of primes. So the first thing I'm going to do is think about how I can split this up into a pair of numbers which multiply to give 72. For instance, I know that 8 times 9 gives me an answer of 72. Because neither 8 or 9 are one of my prime numbers, I need to carry on splitting them up. So this time I can say that 8 is the same as 2 times 4. Because 2 is prime this time, I can circle it, and I don't need to go any further on that branch. But 4 is not, so again I can split that up, and I get 2 times 2. And again, both of the 2's are prime, so I can circle them. Back on the branch with 9, I know that 9 is the same as 3 times by 3, and again at this point, once we've split them up, I know that both of these 3's are prime, so I've figured out all of the prime factors. I can therefore use this tree to help me write 72 as a product of primes. This would be 2 times by 2 times by 2 times 3 times 3. So that's all of the prime numbers from our factor tree multiplied together, and that's a perfectly good answer for a product of primes. However, if it asks you to write it into index form, you need to collect these into powers and say that that's 2 cubed times by 3 squared. The eighth type of question will always ask you to work out a percentage change. In order to do this, you want to write the change as a fraction of the original amount, simplify it, and then convert it to a percentage. So in our question, we want to first consider what the change from 40 to 52 is. That is £12. I want to write that as a fraction over the original amount, which is 40. And if I can, I want to simplify this, so I know that I can divide the top and bottom of this fraction by 4. That would give me 3 over 10. Next thing I want to do is I want to convert this to a percentage. So I know 3 over 10 is the same as 30 over 100. That's if I multiply the top and bottom by 10. And because it's now out of 100, I can say that that's 30%. Because my amount went from 40 to 52, I know that it's a percentage increase, so I can say that it's 30% increase. The ninth type of question will always ask you to estimate an answer to a calculation. Whenever you're asked to estimate, you should always round each value in the calculation to one significant figure. Doing this for our particular example gives us 6 times by 20 on the top, and we want to divide that by 0.3. So that's each of these three numbers in our calculation to one significant figure. I know that on the top 6 times 20 is 120, and we want to divide that by 0.3, and we can write this as an equivalent fraction by timesing the top and bottom by 10, so that's 1200 divided by 3, which is a bit easier to work out. I know that 1200 divided by 3 is 400, so therefore that would be the answer as an estimate to the question. The final type of question will ask you to express a value into standard form. When writing a number in standard form, it's really important that you remember the number at the front must be between 1 and 10, but that doesn't include 10 itself. So in our first example, I know that that number is going to be 3.42, and I'm going to times it by 10 a number of times to get back to the original amount. Because my decimal point is currently here, I need to times by 10 1, 2, 3, 4, 5, 6, 7 times to get back to my original amount, so therefore my answer is 3.42 times 10 to the power of 7. Likewise, in my second example, the number that I'm going to have at the front is going to be 6.54. That means my decimal point would be just here, and this time I'm dividing by 10, so I need to do that 1, 2, 3, 4 times. So I'd write times 10 to the power of minus 4. It's really important you remember the negative sign, because we're not actually timesing by 10, we're dividing by 10, and that's what the negative sign implies. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.